This is Christopher John Björknes. It is September 24th, 2023. I am the world's foremost expert on Albert Einstein's career of plagiarism. I have written many books about it. I have changed the public perception of Einstein around the world. I've proven who he copied from, his failure to give them credit. I've shown that he was accused of plagiarism throughout his lifetime and never responded reasonably to those accusations of plagiarism. You can find my books at my website, CJBBooks.com, and you can see that I've written numerous books. I've given the full history of how he exploited his wife, Mileva Einstein-Marich, and took credit for what she had accomplished, but she was also his partner in crime, plagiarizing the works of Lorentz, Poincaré, Voigt, Larmor, Hilbert, Soldner, Paul Gerber, and countless others. I cover major topics in several different books: E equals mc squared and the mass energy equivalence, the special theory of relativity, the general theory of relativity, how he plagiarized Ludwig Lange's inertial system and inertial reference frames and destroyed Ludwig Lange's life. It's a very interesting story. Lange met Einstein, and Lange published a series of articles exposing the fact that it was Lange, not Einstein, who came up with the inertial system. And I was the first to discover that Samuel Tolver Preston came up with E equals mc squared in 1875 and laid out plans and designs for an atomic bomb and atomic energy. Again, you can find all my books at my website, CJBBooks.com, if you would like to contribute. There are also contribution links at my website. So today I'm going to be discussing the special theory of relativity, and the father of the special theory of relativity, Henri Poincaré. He was the greatest mathematician and physicist of his age, and he took over the theories that were being developed by Larmor and Lorentz, and he perfected them. He created a method for synchronizing clocks, which with light signals, which Albert Einstein plagiarized virtually verbatim. If you take into account translations from French to German, it's literally verbatim in many parts. So I'm going to be proving that today. Henri Poincaré is gaining increasing credit for his work. I've played a major role in that. And we're going to be talking about the relativity of simultaneity, the concept that events which happen at a distance from one another can be simultaneous in one inertial reference frame, but then will not be simultaneous in an inertial reference frame in motion relative to that first inertial reference frame. But don't worry, this is not going to be mathematical. You don't need a background in physics or mathematics to understand what I'm going to be proving today. It's very clear. It's in plain English that everyone should be able to understand. So they're still calling it Einstein's synchronization method of clocks, despite the fact that due to my efforts primarily, they know that Poincaré had come up with it first. They acknowledge that on the Wikipedia page, calling it Einstein synchronization. Einstein was accused directly and repeatedly throughout his life of having plagiarized this from Henri Poincaré. He never took the opportunity to give Poincaré credit or to acknowledge the fact that he had copied this from Poincaré. His paper, written in 1905 and submitted under his wife's name, failed to provide a single reference to the work of Henri Poincaré or to any of the others who developed the special theory of relativity, with the exclusion of reference to an older work of Lorentz. This despite the fact that Albert Einstein was very much aware of their papers, had read them, had studiously studied them, and discussed them with his friends. And Einstein, again, throughout his life, lied and denied, and plagiarized. His whole career was built upon plagiarism, as I've proven in my books. So I think we should look and compare those papers that Poincaré began publishing on this, starting in, I think, 1889, and then going through 1904, which Albert Einstein copied verbatim. Here is Henri Poincaré at the Savoy Conference. I think it was 1911. He is talking to Madame Curie. Albert Einstein is standing behind him over his shoulder, looking for something to plagiarize and steal. This is Hendrik Antoon Lorentz. He was politically aligned with Einstein, and when Poincaré died in 1912, Lorentz began taking credit and was given credit for the Lorentz transformation, which he didn't create. It was created by Voldemar Voigt within a scale factor in 1887, and then it was perfected by Joseph Larmor by 1900. I think he had it by 1898. This is Friedrich Hasenerl, who did all the experimental and conceptual work on E equals mc squared in 1904 that Einstein copied in 1905. And Henri Poincaré had the formula for E equals mc squared in 1900. And Einstein copied that from Poincaré. So the real father of the special theory of relativity as a theory of measurement, as opposed to a theory of the electrodynamics and mechanics of the ether, was Henri Poincaré and not Albert Einstein. And Hermann Minkowski took the idea of four-dimensional space-time directly from Henri Poincaré. He cited Poincaré in some of his papers and acknowledged that Poincaré had come up with the four-dimensional theory first. Albert Einstein actually rejected the idea of space-time together with Jacob Laub for years. And he is still given credit for coming up with the idea of space-time, when in fact he rejected and ridiculed it in a series of papers he wrote together with Jacob Laub. Einstein was not a mathematician. He could not write mathematical papers on his own, and he relied on others. He relied on Jacob Laub, and together they made numerous mistakes. But it is important to understand that Albert Einstein rejected the idea of space-time. He did not come up with it. It was created in the special theory of relativity by Henri Poincaré, combining the ideas of Melchior Peliagi and Henri Poincaré. Hermann Minkowski then wrote papers on time-space and created Minkowski space-time, despite the fact that Einstein's given credit for it and despite the fact that he ridiculed the idea. So, this is what Einstein submitted in 1905, and we know that the paper was submitted under the name Einstein Merity, which was his wife's name. Merity was a variant of Marich, and she was the actual author of the paper. But in that paper, it starts off immediately after the introduction. So this shows how vital this is to the formulation of the special theory of relativity. That Einstein copied from Henri Poincaré. And it states, Section 1, kinematical part, definition of simultaneity. And this is really what distinguishes the work of Poincaré from that of Voigt, Larmor, Lorentz, Fitzgerald, and the other predecessors. And this is what really, truly makes the theory Poincaré's, the special theory of relativity. And this is how Albert Einstein and Mileva Maric plagiarized it from Poincaré. They also plagiarized Ludwig Lange's concept of the inertial reference frame. Definition of simultaneity. Let us take a system of coordinates in which the equations of Newtonian mechanics hold good. This footnote did not appear in the original paper, nor did this other footnote that says the preceding memoir by Lorentz was not at this time known to the author. We know that that was a lie because Einstein gave a lecture in Japan in which he admitted that he was aware of Lorentz's famous paper of 1904, in which Lorentz presented the complete and perfected Lorentz transformation for the first time, despite the fact that Joseph Larmor had it by 1898 and published it in his book On the Ether in 1900. Let us take a look at a system of coordinates in which the equations of Newtonian mechanics hold good. In order to render our presentation more precise and to distinguish this system of coordinates verbally from others which will be introduced hereafter, we will call it the stationary system. This is referring to absolute space. In the German, it actually says the resting system. So Einstein was still working with the conceptions of Larmor and Lorentz, that there was an absolute space, but Henri Poincaré had already progressed well beyond that, especially in his papers of 1905, which preceded Einstein's paper of 1905. If a material point is at rest relatively to this system of coordinates, its position can be defined relatively thereto by the employment of rigid standards of measurement, and the methods of Euclidean geometry can be expressed in Cartesian coordinates. If we wish to describe the motion of a material point, we will give the value of its coordinates as functions of the time. Now we must bear carefully in mind that a mathematical description of this kind has no physical meaning unless we are quite clear as to what we understand by time. We have to take into account that all our judgments in which time plays a part are always judgments of simultaneous events. If, for instance, I say that the train arrives here at 7 o'clock, I mean something like this. The pointing of the small hand of my watch to 7 and the arrival of the train are simultaneous events. It might appear possible to overcome all the difficulties attending the definition of time by substituting the position of the small hand of my watch for time. And in fact, such a definition is satisfactory when we are concerned with defining a time exclusively for the place where the watch is located. But it is no longer satisfactory when we have to connect in time series of events occurring at different places. or what comes to the same thing, to evaluate the times of events occurring at places remote from the watch. We might, of course, content ourselves with time values determined by an observer stationed together with the watch at the origin of the coordinates, and coordinating the corresponding positions of the hands with light signals, given out by every event to be timed and reaching him through empty space. But this coordination has the disadvantage that it is not independent of the standpoint of the observer with the watch or clock, as we know from experience. We arrive at a much more practical determination along the following line of thought. And now he really begins to directly plagiarize exactly what Poincaré had written before him. If at the point A of space there is a clock, an observer at A can determine by the time values of events in the immediate proximity of A by finding the positions of the hands which are simultaneous with these events. If there is at the point B of space another clock in all respects resembling the one at A, it is possible for an observer at B to determine the time values of events in the immediate neighborhood of B. But it is not possible without further assumption to compare, in respect of time, an event at A with an event at B. We have so far defined only an A time and a B time. We have not defined a common time for A and B, for the latter cannot be defined at all unless we establish by definition that the time required by light to travel from A to B equals the time it requires to travel from B to A. Let a ray of light start at A time T sub A from A towards B, and let it at the B time T sub B be reflected at B in the direction of A and arrive again at A at the A time T sub B prime. In accordance with definition, the two clocks synchronize if T sub B minus T sub A equals T sub A prime minus T sub B. We assume that this definition of synchronism is free from contradictions and possible for any number of points, and that the following relations are universally valid. If the clock at B synchronizes with the clock at A, the clock at A synchronizes with the clock at B. If the clock at A synchronizes with the clock at B and also with the clock at C, the clocks at B and C also synchronize with each other. Thus, with the help of certain imaginary physical experiments, we have settled what is to be understood by synchronous stationary clocks located at different places and have evidently obtained a definition of simultaneous or synchronous, and of time. The time of an event is that which is given simultaneously with the event by a stationary clock located at the place of the event, this clock being synchronous, and indeed synchronous for all time determinations with a specified resting clock. In agreement with experience, we further assume the quantity 2AB divided by T sub A prime minus T sub A equals C to be a universal constant, the velocity of light in empty space. And that's what makes all of these assumptions valid, is the initial assumption that the velocity of light is a constant, and it's taken as a constant because it had been proven experimentally that it is a constant, and because axiomatically in empty space, in the resting system, in absolute space, which was understood to be the ether at rest, it would be a universal constant. It would be isotropic and homogeneous. It is essential to have time defined by means of stationary clocks in the stationary system. Again, in the German, Maleva wrote resting clocks in the resting system, referring to absolute space. And the time now defined being appropriate to the resting system, we call it the time of the resting system. This is the crux of the special theory of relativity, and I'm about to show you that this is a direct and nearly verbatim plagiarism of what Henri Poincaré had been writing for a very long time prior to this late, I think it was September, it was submitted 1905 paper on the special theory of relativity. Poincaré wrote in 1898 in his article La mesure du temps, revue du métaphysique et du moral, that was republished in English in 1904 in his book, The Value of Science. I'm sorry, 1907 in English, but it had been reprinted in French in 1904. But let us pass to examples less artificial to understand the definition implicitly supposed by the savants. Let us watch them at work and look for the rules by which they investigate simultaneity. I will take two simple examples, the measurement of the velocity of light and the determination of longitude. Again, this is 7 years before Maleva and Albert's paper. When an astronomer tells me that some stellar phenomenon which his telescope reveals to him at this moment happened nevertheless 50 years ago, I seek his meaning. And to that end, I shall ask him, first, how he knows it, that is, how he has measured the velocity of light. He has begun by supposing that light has a constant velocity. Remember, Einstein's talking about the constant velocity of light, and in particular, that its velocity is the same in all directions. It is homogeneous and isotropic. That is a postulate. Einstein referred to the two postulates. That's one of them. That is a postulate without which no measurement of this velocity could be attempted. The postulate could never be verified directly by experiment. It might be contradicted by it if the results of different measurements were not concordant. We should think ourselves fortunate that this contradiction has not happened, and that the slight discordances which may happen can be readily explained. The Michelson-Morley experiments supposedly demonstrated that. The postulate, at all events, resembling the principle of sufficient reason, has been accepted by everybody. What I wish to emphasize is that it furnishes us with a new rule for the investigation of simultaneity, entirely different from that which we have enunciated above. This postulate assumed, let us see how the velocity of light has been measured. You know that Römer used eclipses of the satellites of Jupiter and sought how much the event fell behind its prediction. But how is this prediction made? It is by the aid of astronomic laws, for instance, Newton's law. Could not the observed facts just as well be just as well explained if we attributed to the velocity of light a little different value from that adopted and suppose Newton's laws only approximate? So that was 1898. Poincaré is discussing the fact that the velocity of light is considered to be a constant, and that simultaneity can only be determined based upon the measurement and the presumption that the velocity of light is a constant. Poincaré then went further. This was 1901. Allow me a couple of remarks regarding the new variable t prime. It is what Lorentz calls the local time. Voigt had this back in 1887. At a different point, t and t prime will not differ, but by a constant. T prime will, therefore, always represent the time, but the origin of the times being different for the different points serves as justification for his designation. Jacob Laub tried to give Einstein credit for the idea that there was no difference, that t did not represent absolute time, and t prime, local time. Instead, all time is relative. But Einstein said no such thing. It was actually Poincaré who came up with that and said that there was no such thing as absolute time or absolute space. And he said that many years before Einstein. And Einstein didn't actually believe it until much later, if ever. This is from 1900. In order for the compensation, and again, this is Henri Poincaré. In order for the compensation to occur, the phenomena must correspond not to the true time t, but to some determined local time t prime defined in the following way. And Poincaré fully understood that there was no true time t. He was simply trying to enable his readers to understand what it is that he was saying, and he was utilizing the current common conceptions of physicists. I suppose that observers located at different points synchronize their watches with the aid of light signals. This is 1900, at least 5 years before the Einsteins copied what he's saying directly, which they attempt to adjust to the time of the transmission of these signals. But these observers are unaware of their movement of translation, and they consequently believe that the signals travel at the same speed in both directions. They restrict themselves to crossing the observations, sending a signal from A to B. The Einsteins even utilized the same A to B. Then another from B to A. The local time, T prime, is the time determined by watches synchronized in this manner. If in such a case v equals 1 divided by the square root of k sub 0 is the speed of light, and v the translation of the Earth, that I imagine to be parallel to the positive x-axis, one will have t prime equals t minus vx divided by v squared. There is Henri Poincaré, and this is what he wrote in 1902. There is no absolute space, and we only conceive of relative motion. He had the theory of relativity long before Einstein. And yet, in most cases, mechanical facts are enunciated as if there is an absolute space to which they can be referred. There is no absolute time. This is one of the things that Einstein apologists lie about by claiming that Poincaré believed in absolute time, but it was Einstein who eliminated absolute time. Minkowski was another one who tried to give Einstein credit for that, but it's absolutely not true. When we say that two periods are equal, the statement has no meaning and can only acquire a meaning by a convention. Not only have we no direct intuition of the equality of two periods, but we have not even direct intuition of the simultaneity of two events occurring in two different places. I have explained this in an article entitled Mesure du temps, Revue du métaphysique et du moral, Volume 6, pages 1 to 13, January 1898. Finally, it is not our Euclidean, is it not, finally, is not our Euclidean geometry in itself only a kind of convention of language? Mechanical facts might not be enunciated with reference. Mechanical facts might be enunciated with reference to a non-Euclidean space, which would be less convenient, but quite as legitimate as our ordinary space. The enunciation would become more complicated, but it still would be possible. This is foreshadowing the general theory of relativity and tangentially making reference to Riemannian geometry. Thus, absolute space, absolute time, and even geometry are not conditions which are imposed on mechanics. All these things no more existed before mechanics than the French language can be logically said to have existed before the truths which are expressed in French. We might endeavor to enunciate the fundamental law of mechanics in a language independent of all these. Poincaré gave a lecture at the, I think it was the St. Louis World's Fair or something like that, something that was taking place in St. Louis. And he said, among many of the things that the Einsteins plagiarized from him, imagine two observers who wish to adjust their watches by optical signals. They exchange signals, but as they know that the transmission of light is not instantaneous, they take care not to cross them. When the station B perceives the signal from the station A, its clock should not mark the same hour as that of the station A at the moment of sending the signal, but this hour augmented by a constant representing the duration of the transmission. Suppose, for example, that the station A sends its signal when its clock marks the hour 0, and that the station B perceives it when its clock marks the hour t. The clocks are adjusted if the slowness equal to t represents the duration of the transmission. And to verify it, the station B sends in its turn a signal when its clock marks 0. Then the station A should perceive it when its clock marks t. The timepieces are then adjusted, and in fact, they mark the same hour at the same physical instant, but on one condition, namely that the two stations are fixed, as in at rest. In the contrary case, the duration of the transmission will not be the same in the two senses, since the station A, for example, moves forward to meet the optical perturbation, meaning light, emanating from B, while the station B flies away before the perturbation emanating from A. The watches adjusted in that manner do not mark, therefore, the true time. They mark what one may call the local time. He's using Lorentz's language, so that one of them goes slow on the other. It matters little, since we have no means of perceiving it. All the phenomena which happen at A, for example, will be late, but all will be equally so, and the observer who ascertains them will not perceive it, since his watch is slow. So, as the principle of relativity would have it, he will have no means of knowing whether he is at rest or absolute motion. Therein lies the theory of relativity and how it distinguishes it from classical mechanics and the idea that the ether frame can never be detected, because all the same laws apply in every inertial reference frame, and therefore there is no means of determining what is the inertial reference frame of the resting ether. And that is the principle of relativity. Poincaré enunciated the principle of relativity many years before Mileva and Albert Einstein reiterated it without giving reference to Poincaré in the exact same terms. And that's going to be part 2 of this series, where I show to you the absolute proof that the Einsteins copied the principle of relativity from Henri Poincaré, just as they copied the clock synchronization method and the concept and principle of relative simultaneity directly from Poincaré, and in the exact same terms and with the exact same thought experiment that they plagiarized from Einstein. And in my books, I prove that all of Albert Einstein's thought experiments were directly plagiarized from others, not just Poincaré, but also from Kenersha and numerous other people. So please have a look at my website, cjbbooks.com. Pick up one of my books, study up on it, and you'll discover that Albert Einstein was a career plagiarist. Historians, his fellow physicists and friends, gave him cover, but there were always historians and other Nobel Prize laureate physicists who accused Albert Einstein of plagiarism directly to his face, and he had no response except to smear them in the popular press and hide from their accusations. So I hope you enjoyed this. I plan to do a series of these videos providing the primary proof evidence of the fact that Albert Einstein was a shameless career plagiarist. And I'll also show some of the accusations leveled against Einstein by his contemporaries, his Weasley response to get out of it. I'm going to talk about how he hid from his critics. He ran away from a debate with Philip Leonard during the lunch break after Leonard had slaughtered him in the debate, and he was so scared that he was going to run away from Germany and hide for the rest of his life. And we have a letter proving that. But press, which was friendly to him in Germany, rescued him and smeared his critics and avoided addressing all of their accusations. And his friend Max Planck and others covered for him. It was terribly, terribly corrupt. And the history is still corrupt. It's ridiculous. Even after the publication of all my books and all the work I've been doing on the internet to expose this for 30 years, they still terribly lie to the public about the history of the theory of relativity, and they call it Einstein's when it clearly was not. So please like, share, and subscribe. Pay a visit to my website, cjbbooks.com. Pick up a couple of my books. You're going to learn a lot. You're going to learn that all of this is absolutely proven and beyond any legitimate debate or dispute. And please remember the clock synchronization procedure and the principle of relative simultaneity belong directly to Poincaré. And maybe I'll do a video showing some of his predecessors, but he was the one who incorporated it all into the special theory of relativity, and he was the father of the special theory of relativity, despite the fact that his friend, Hendrik Antoon Lorentz, would later lie about it after his death, and Lorentz was given credit for the Lorentz transformation, which was actually first formulated within a scale factor by Voldemar Voigt, and then was later perfected long before Lorentz caught on by Joseph Larmor. So look forward to my next video, where I'm going to be talking about the principle of relativity that Einstein is so popularly given credit for, but which was clearly enunciated long before him by Henri Poincaré in the exact terms that he plagiarized, he and his wife Mileva plagiarized directly from Poincaré. Thank you all for watching. I will see you next time. Please donate if you can. There are donation links at my website. I need funding to keep going at this, and I appreciate all of those of you who have been donating and contributing. Thank you so very much. I'll see you next time. Bye for now.